G'day, welcome to episode 3 of Core Electronics Live. Today, it's May the 4th, I'm seeing lots of Star Wars stuff getting around, which is great. But talking about something else, Raspberry Pi recently released their HQ camera, and I've got one here on the bench, along with the 6mm wide and the 16mm telephoto, and we'll have a bit of a look-see. You know, I first saw this camera a few months ago in the UK when visiting Raspberry Pi. Wasn't allowed to talk about it, but today I can. And better still, I've got it on the bench, and I've changed a few things around here so we can do some practical tests with it. And I'll show you how to set it up, how to adjust the the focus and the aperture, and we'll get hands on with it. Before we do, though, it's worth mentioning that there's a great video by the Pi Foundation, and I just absolutely have to show you it. I'll just prepare it over here, and while I do, I'll just make sure that things are working fine with the stream. We're on Facebook, YouTube, Twitter, Periscope. If you're on any of those platforms, feel free to say hello. I'll do my best to copy you in on the live stream. Last time I had a bit of a glitch getting those comments working. Hopefully it's on today, but the YouTube API for comments is not as good as it used to be because it seems to be a little bit under pressure with all the live streams going on. So yeah, if I see a comment come through, I'll do my best to share it. But let's head over to the Core Electronics website, and if you're familiar with the homepage, you'll see something new load just about here, the video for the new camera. Let's have a look because it is great. How good does that look? Nice. So really excited to see this. That's the intro video, and they sort of touch on a couple of features that are a part of the Pi camera. So I'll just head over here and I'll just prep this next part of the video. Great. Again, welcome if you just joined in. You're listening to and you're watching Core Electronics Live. So here it is. This is the Raspberry Pi camera. Comes in this little box, and I'll switch over to the top-down camera, and let's get that in focus, shall we? So the box itself is like more of a tall rectangular shape, and inside, this is exactly what you'll get, all going well, is the camera itself. I'll put that down on the bench there. And don't forget, there's a little paper envelope here. Paper envelope has a tiny little screw and a little screwdriver. You'll need this if you're tightening things up and sort of leaving the camera in more of a finished configuration. But today we'll just do a little bit of light experimentation. But normally that little screw would go on the top here. And just to help out those that if you do run into any problems following anything I'm explaining today, just go to the product page, scroll down, and then download the Getting Started guide. That'll cover off on what screws go where and how to use each of these lenses together with the camera itself. So let's have a little chat about this camera. So it's 12 megapixels. Well, 12.3. Let's not forget the 0.3. And that's a big deal because while it's a high resolution, there's also twice the amount of pixel area for every pixel. So it's a much larger sensor, better quality data. And so you're dealing with something that has much better output. It's got focus. Well, the lenses have focus. You can mount both C and CS mount lenses. It also has an infrared cut filter, and there's a ribbon cable attached, and it has a tripod mount on the bottom here. So I'll just try and get the light there. There we go. So this can be mounted on standard 1/4 inch 20 per thread tripod mounts like this little guy here, which we'll have a muck around with shortly. Great. And I'll just double check these comments, because if you're on Facebook or YouTube, give us a yell. Let us know that you can hear the audio coming through okay. And I'll just double check that this is linked up properly. Right, just going into these settings. Oh, I had to fix something on the YouTube one. There we go. Oh, and the Facebook. That should help. Okay, that setting should help with getting Facebook in the mix as well. Well, hopefully everyone can hear me okay. Let's kick on with this hands-on little exploration with the new HQ camera. So C and CS mount lenses. That's something that you may not have seen all the time and or much before, but basically it's a type of lens that will fit into a much larger metallic sort of thread insert. And if I switch over to the monitor here, I'll show you the difference between them mechanically. So I've just Googled C versus CS mount, and this is a great example. You can see here on the right-hand side the CS mount, and you might just be able to read it, is 12.5 millimeters from the back of the lens to the sensor. And the C mount is a little bit longer between those two, so it's 5 millimeters longer. And that's basically coming back to the top down. Thanks guys on YouTube. Ted, loud and clear, good to hear. So I'll just untwist this C-mount adapter. So with this ring removed, that is this is now ready for CS mount. So it's 5 millimeters shorter into where the sensor is. Fitting this this adapter will turn the camera into a C mount fitting. So that's quite important because first of all, there are two different types of lenses out of the box. Let's have a look at those, and I'll just put that back on there so I can put my dust cap on. So the first one here is it comes in a box like this. This is the 6mm lens. And inside we have the lens itself. Nifty looking thing, really sturdy. It's like it's got some weight to it. A nice little cap on the front and the back. But that's this one here, the smaller 6mm one, is the CS mount. So you'll want to have removed that ring to fit this device. So I'll put that guy over there. And then here we have the telephoto. So we'll power these up in a moment, and we'll go through the settings and how you adjust them. Just coax that out of the container. But here we go. So the front cap I just took off while I was taking it out, but that's the 16mm telephoto. Look at this thing. It's a juggernaut of a lens compared to what we've traditionally seen for the Raspberry Pi camera lineup. Coming from the version 2 camera, which had a like the infinite focus, which is cool, but you've got far less control. Like you can't focus the things that are very close. You have to deal with it. It was about 40, 50, 60 centimeters, somewhere around there was the minimum focal distance to infinity, and you're just locked in. You have to use what you've got. Whereas both of these lenses have a dial to control the aperture and the focus separately. And I'll show you how to do that in a moment. Righto. So before I jump too far into this, I'm going to show you the setup. So this is my setup. I took a photo of it a moment ago. You can and I'll just switch the screen over. So you've got the tripod on one side of my bench, which is about here. And then 600 millimeters away, so 60 centimeters away, which is why I've got that ruler, is the little Lego town that I've reused. I made this for a different video way back when, and I'm reusing it for this because it's there's lots of color, and it is a little bit of a stress test. Like, granted, it's not going to be. I'm not out in a park. I don't have like lots of sunlight or anything. I'm inside a room with fluorescent bulbs, and but we'll still put it through its paces, because I would imagine a lot of the experimentation and first use of these lenses and this camera would be in a similar environment on the bench, checking out how the focal and aperture rings work. So let's prep this guy and get it going. So I'm just going to screw in the tripod onto this bottom part here. Good idea just to keep the dust cap on while you're handling it. You don't want to touch that sensor. You don't want to get stuff inside there. Treat it like a, and while it's a lot less expensive than a digital SLR, definitely treat it with a little bit of respect. And the first lens we're going to test will be the 6mm, and I'll just double check a setting here. Yep, great. So the 6mm, it's a CS adapter. So I'm going to remove the little focus, the C to CS adapter. And let's grab the 6mm. So the 6mm, just like the telephoto, has the 2 adjustment rings, one for aperture, one for focus. And I'll take the back plate, the back cover off. And fit that directly. So just make sure, so a trick for new players, make sure that your C to CS adapter is removed, and then this assembly does have a little bit of play to it. So that would be removed if I was to fit this this small screw with the screwdriver, which would go in there. But for today, I'm just going to make this nice and easy to do some quick experiments on the bench, and I'll do that up just hand tight. Don't have to overdo anything with this lens. If you do have a little tripod, make sure that the one of the long edges is in line with the lens itself. That's because there's a fair bit of weight, and it's going to want to push down. So I'll set this up at the end of the ruler here, because I'm quite interested to see what the closest focus distance is for each of these lenses. That's a fairly important feature with lenses. Righto, so we've got this little ribbon cable. This one was fitted to the Raspberry Pi. You'll see one side of the ribbon cable has blue, and the other side has these little copper, or not copper, but they're tin pads. Now, if you are plugging it into this side because you removed it for some reason, maybe you fitted a longer one, or you've removed this for some reason, make sure that the pads go down. And you can tell because when you look into this connector with a bit of light, you'll see the the shiny surfaces of the pads, which are on the bottom side of this connector. So just make sure they're electrically touching. It's pretty easy to put it in the wrong way and things don't work. So I moved the camera forward a little bit so I can bring the Raspberry Pi in the shot. So got our Raspberry Pi. Again, got our pads on one edge here. And as I look down into this connector, I can see that there are little shiny parts of the connector on the left-hand side of it. And this, by the way, is the camera connector. So only while it will fit into both, please only put it into this one. I believe Raspberry Pi Foundation took a photo of the board with the Raspberry Pi connected to the wrong connector, but people on Twitter quickly helped them. I'm just going to spin this around, a little bit tricky from that angle. There we go. So these little connectors here, they're quite fragile. Like, they're not just going to break and shatter, but if you're putting a lot of force on them, something's wrong. Like, just have a rethink and give it a go with a different angle, or try and reseat it again. Right, so that's the setup for my camera. Quite happy with that. I'll take off the front lens, and I'll also set up the Raspberry Pi. So clear some room off my bench. Which reminds me, I forgot to play the on the bench intro for this segment. We only have on the bench and Ask a Maker today because there's a lot going on with the camera. So I'll plug in the USB-C power. I'll just remove this little screw so I don't short out my Raspberry Pi. And let's turn it on. All going well. I'm going to, here we go, let's switch over to my Raspberry Pi. Got our rainbow screen, it'll go through the boot sequence. All I've done is downloaded a fresh copy of Raspbian. The torrent's actually a lot faster. If you're downloading Raspbian, the full version for the first time, you may as well just, oh, a message here from Ian. I'll just bring that up so everyone can jump in. So Ian says, is there a UV filter to screw on to prevent scratching? I think you're referring to like the UV filters that typically would go onto the outside edge of a lens. There aren't any yet that I'm aware of. There is a little bit of a thread here, so probably you can get a like a lens filter cover on the end of this, like you could a traditional DSLR. But not at the time of writing do these little lenses come with any other modifications or accessories. But they are C and CS mount lenses, so you'll probably find that there are lots of choices out there besides the two that Raspberry Pi Foundation have launched with. I hope that helps, Ian. So Raspbian's booted up, and I'll just make my way over to the terminal. And for those that aren't familiar, you've got terminal. Terminal's just an easy way to experiment with stuff on the Raspberry Pi. I'm going to use the rasbistill command, which is just like one of the stock standard functions or features on the Raspberry Pi to work with the older camera, and of course the newer one. They have fully supported it. And so what I'll do, I'll just try and make this font a bit larger. There we go. Hopefully you can read that. So this time around though, I will add an argument just to extend the amount of time that I get with my preview. So this is the command I'm running. I've added a new option and I've added 120,000 milliseconds. So that's going to be 120 seconds, aka 2 minutes. And then it will take a picture and save it to my home directory as cam.jpg. This is probably just the easiest way to get up and running. There's so many ways to use the camera, but I'm just doing it this way. You could stream video, you could do time-lapse stuff. I'll include some links after this live stream for different projects that you could do with your camera. But for now, if I was to hit enter, I'm going to get a preview, all going well, of the setup. So this being a 6mm lens, I get less zoom, so I'm just going to physically move this a little bit closer to sort of get a natural position here, looking at this setup. And I'll bend it down a little bit so we've got more of the Lego in view. There we go. So that there, so the front of the lens as I look down is about 300mm from this Lego set. And again, a reminder, this is the setup, a photo of the setup. So I've currently moved the camera within 30 centimeters of that setup right there. And these little adjustment rings, I recommend just loosening off and I'll just switch to the top down. This being the top down, you can loosen these grub screws, and I recommend only like leaving the focus one, leaving the rear one tight, and just loosen off one at a time to make these adjustments one by one. And so I'm just going to leave the back one tight, and I'll go back to the RPi. There we go. So the front one, I'm going to adjust aperture, which is opening and closing the amount of light that comes in. So I'm going to get it to somewhere where I think is about right for this little experiment. It's obviously not perfect because I'll now loosen off the back one and move both of these at the same time, the front two parts, and I'm gonna try and get it in focus. So looking at that monitor, I think that's about as close as I can get it in focus, and I'll lock that off, and then I'll just do a little adjustment to the aperture. So I have changed what's going on. Oop, I'll rerun my script because my 2 minutes has run out. So I'll just make a small adjustment to the aperture here, just to bring a little bit more light in, and let's just fix that focus. There we go. Not too bad. Well, for live streaming, this is going okay. Lots of moving parts, lots of videography, inputs going everywhere. But there we have it. We've got the our little Lego scene. I've focused the 6mm. I've had to physically move it a bit closer because it is a very wide lens. But let's have a look now at how close we can actually get a subject or something in front of that lens. And oh, Ian's just mentioned, and I'll just share this with everybody. So Ian mentions it's a copy from the Pi Foundation that they're expecting people to use a wide variety lenses, but for starters, they're launching with the 6mm and the 16mm telefocal. So yep, spot on, Ian. Nice find. So let's bring our Lego guy right up here. Now I had to play with this before, so I'm just going to jump straight to it. I know it can go fairly close, so I'm just going to find out how to get this as close as possible. Geez, that's not too bad. The light is also quite good, and so I'm just going to loosen off the focal ring, and now adjust the focus. I need to bring this closer in. Oop, that's going further away. So I could focus to basically out to infinity, but what's the closest I can do, which is a bit of a stress test for lenses, and like I know it goes closer. I had this within like 4mm or so, and I could basically get. Let's bring that preview back up. I could get right in on the whiskers. It's this 6mm wide is the way to go if you want to experiment with macro. If you want to get up really close to get as many pixels as possible worth of data onto your Raspberry Pi, into your Python script, whether you're running CV or other projects, computer vision that is, and you're going to get as many pixels as possible into that lens, into that sensor. So that's great for macro and also good for wide. So you think more like traditional wide area views of people moving back and forward or workplace. You might find that, or you want like wide, landscape type images. This is a nice little lens to experiment with. Okay, well, if you've got any questions about the 6mm lens, give us a yell. If not, I'm going to jump over to the 16 telephoto. So I'll remove this lens. Oh, Ian's got a comment. I'll just share that. Ian says, holy moly, that's awesome for macro underwater photography. Yeah, you will need an underwater enclosure, but yeah, why not? It definitely lets a lot of light in, which is nice, and I think it would work quite well underwater for getting that wide angle. But it'll be interesting to see how people go about building, like what the maker community does, building different enclosures, cases, using this device in all sorts of unique and interesting ways. It's exciting to see what happens with this. But so thanks for sharing that, Ian. Good point. Definitely put on your caps afterwards, because these are optics, so you don't want dust and stuff getting inside. And a trick for new players, when you're putting this back inside, just make sure that with these screws, make sure they're opposing, so they're on opposite sides. or they can be both on the same side, but this particular one works best when they're opposing. And I'll just tighten this back up because I did do a bit of a stress test there with the focus. And that way, when you put them inside the case, they're gonna make their way into either side. And oh, this is obviously the larger case. I thought that wasn't very snug. It's this one. There we go. So great little case to keep it in, safe for transit and just throwing into your backpack. So let's grab the 16mm. So this guy is a lot bigger. This is the one that you saw on that video way at the beginning. And for those that have just joined us, welcome. You're watching Core Electronics Live, and this lens that I'm about to demo is the one that's inside the Raspberry Pi feature video. So the 16mm telefocal, which means it's telephoto, which means you can essentially zoom into that shot. As you adjust that, you are going to change the aperture, but pretty cool lens, because this is the sort of thing that you'd use to do outdoor photography, landscape photography. Of course, we're talking about a little lens here. It's nothing like a big Canon or Nikon lens, but still a whole lot of fun. And more importantly, it makes it very useful for computing projects that need vision, because now you have a much better optic system that's going to a much better high quality camera with a 12.8 megapixel sensor, and a big sensor as well. So there's twice as much data hitting that sensor itself. So this guy is going to need the C to CS adapter. And when you're fitting this, essentially this adds an extra 5 millimeters of distance between the lens and the sensor itself. So just going to put that on there, finger tight. And now to fit it to the camera itself. And taking the front cover off. This one's like much more important that you have the front of this tripod going in the direction of the lens, because it is actually quite heavy. Like let me just demo this. It is definitely a real problem. Without that, it just wants to topple. So that's how you can add a little bit of safety. But it is a very small tripod, so the center of gravity it's not very well balanced, but it's definitely good enough for a bench guide today. So that's the lens setup. Now let's head over to the Raspberry Pi. And have a look. So I think I've actually set this up for macro. I think that was the last thing that I have changed the focus on this. So we'll start with the same test, shall we? I'll put the fire truck way back there, and let's adjust the back one first and then the front. So the front is basically your the telephoto part of this lens. So I'm able to zoom in or zoom out. Obviously, that's not going to make a whole lot of difference on such a small lens, but I can also change the aperture here, and I'll lock that off. And let's get that zoom, that focus looking good. It's not too bad. I'll just open up that lens a little bit, a bit more aperture to increase the amount of light going into the lens and to the sensor. And I'm sure the live stream doesn't give this the justice, but this is definitely a little bit. It's a higher quality than the 6mm, that's for sure. And to give you an idea of the zoom on this, I'm going to move this right up to where I had the 6mm. And before we had the 6mm, that whole scene in shot. And so I'm about 30 centimeters away, and now you can see what the effect of that zoom does with the 16mm lens. So I'll move it right back to the 60 centimeter point, and I'll just adjust this a little bit and refocus that. Now, if you can't get your focus to work, it's probably because you don't have the C to CS mount fitted. So it's just going to change the optics entirely, and you're in for a ride. So that's basically that's what it looks like for the 16 mil lens, and we'll bring in for a macro test like what the closest possible distance is that we can get get something to the lens itself, and it will not be anywhere near as macro as the other lens, but we'll give it a fair go. So I'm gonna zoom this right in as close as I can, and basically, where does this guy appear in focus? And I guess that it's about there. So as I look at this, and I'll just remind you, the setup. So I've got the ruler there, so I can actually see how far away it is, and so that is about 290 millimeters. So I'll find what the exact distance is that the closest that we can focus this, but I'm not surprised. This is certainly not a macro lens. It's more for outdoor landscape and lots of light. But at the same time, you've got a bit more zoom. It punches in a little bit more, and you might find that handy for a range of projects. So that's both of the lenses and the camera itself. So again, any questions that you might have in between, feel free to ask them on Facebook, Twitter, YouTube, Periscope, and I'll do my best to help out along the way. But we'll switch over to the next segment. Ooh, nearly dropped it. And that is righto. So ask a maker, and I'll just balance this camera so it doesn't drop during the next part. So first of all, big shout out to a couple of makers that have been helping out quite a lot on our community forum. So Abraham, really enjoyed reading your perspective of the support you've been helping out on the forum with, along with Wayne. Welcome Wayne, and you've had some great insights along the way, and of course Robin. Robin, thanks again. I really appreciate we all really appreciate your support, and it's great to see other makers getting in there and working together to solve problems and to build projects. The first question that I'll jump in and do my best to help with is a question from David, and I'll just zoom in a little bit here. So David asks, he's been trying to fix a Bluetooth headset, getting a lot of noise in the headset, and when he touches the wire, the noise goes away. Thinks it's a grounding issue, and yeah, it's probably a grounding issue. So my advice here is, and I've just done a quick Google for shielded audio cable. You've got some different types of audio cable. I'm not sure which particular version you're using, but here we've got an example of them both combined or in separate sheaths. You're probably using something like this. The best way to go about audio cabling is shield it, but shield it from both, ground the shield on both sides, and make sure the ground is going to a good ground plane, that it's not going to like a spot where other noise and harmonics might be coming into that equation. It'd be interesting to know if that's what you've done already, and if not, what the setup is, like how you've grounded both sides of that cable. So a question here from Angus. Sorry, this isn't from Angus. This is a comment right at the bottom of this project post, and Alyssa asks, what does the 100 and 250 values mean, and how do I adjust them to make them louder? So Angus shared a project on how to build a thermometer system for cooking, and it has a little readout and a buzzer. And in that project, which is a great write-up, thanks for sharing this, Angus. We've got the schematic itself, and in the code, he's actually using the tone function, and is setting from the Arduino, sending a tone with these two parameters, and Alyssa's asking what are they. So good question, Alyssa. When you're copying and pasting code, it can be very easy to overlook what the original reason for that code was. But if you Google Arduino reference, you'll find the Arduino reference website and make your way down to, and basically here, these commands are all of the commands that are available natively with Arduino, all of these functions. And if I just do a search for tone, I'll find tone in the list, and I'll zoom in a bit more. I've clicked on tone. I'm now viewing the tone write up, and tone has at least 2 arguments, one for pin and one for frequency. And there is an alternate syntax where you've got pin, frequency, and duration. So in the case of Angus's project, defining the pin as buzzer, which is is a constant. It's linked to a pin number. Setting the frequency to 1000 and the duration to 250. So it's like a beep, a 1 kilohertz beep for 250 milliseconds. So I hope that helps, and I'll share this in the forum afterwards. Eric is using a PyCom PyPy and is having trouble connecting or updating the real-time clock. I shared some source code here, which is great. And this is the result you're getting by the looks of things, Eric, where it connects, everything's working well, and then you're getting it just never connects to RTC. So yeah, a bit of a tricky one, but perhaps first just try and ping something, try and test the internet in general. Ping a direct IP address like Google 8.8.8.8, and or something that's relative to your region that you should have easy access to. And if that doesn't work, if that does work, then maybe there's a problem with your network trying to access that particular time server, and have a little look-see. If that doesn't work, then perhaps the SIM card or the telco that you've connected with doesn't support that device yet. Reach out to PyCom, ask them if they can help with that. They're definitely the original equipment manufacturers for it, and they ought to be able to help with why that would be the case. I hope that helps, Eric. Pavel asks, as mentioned, they've got a Pololu G2 power motor driver, so an 18V25, and has a question about the performance by adding a heatsink, and has had a really good scour of the internet having a read of this. So for those that aren't familiar with this motor driver, here it is. It's quite good. It's definitely designed for like mid to high range power for motor control. On the top, you have your capacitors and some other devices. Underneath, you have your MOSFETs and some other control devices. The PCB itself has got lots of planes on it to help dissipate heat as best as it can. And in the overview, there is a section, if I remember, for managing power. Here we go, real world power dissipation considerations. So this is a great little write-up, and I'll link this reply into the forum. But what you won't be able to find like strict guidance on how to go about this. You're best applying some thin heat transfer tape to those MOSFETs, putting a heatsink that can cover all of them, and as big as you can get it that's appropriate for that device. And that's just going to help a lot with reducing the amount of heat that those MOSFETs get. And the reason why you won't find like firm advice when and when not to use the heatsink is because there are 2 variables. The first is the amount of current going through the MOSFET, and then the second is how fast you're switching that MOSFET. So between those 2 things, there's a bit of fluctuation going on. So you can imagine all the different variations of temperature junction charts to show you when and when not to use a heatsink. But it's not really designed to be run into to the brim of failure. If you're keeping this below like what would be the equivalent to a 25 amp continuous, which is a lot of power for a little motor. For bigger motors, it's not even a lick of power. It's not even enough to get them going. But that is a lot for general hobbyist type motors. And if you're within that range, it should be easy going. Now, if you are switching that MOSFET on and off, you are going to generate heat when the MOSFET turns on during the ramp from infinite resistance to nearly nothing. There will be a moment in time where the resistance is something and it's not 0. and that's going to trigger heat as the MOSFET ramps up or ramps down. So keep that in mind. And if you're unsure, I guess you could use like thermal monitoring to a FLIR camera or something to that effect to monitor it. But you're definitely going to you want to fit a big juicy heatsink if you are going to be running it around those specs, or you're going to be switching it on and off with fast PWM. So a little bit of experimentation, maybe a bit of a sweat test, get it on the bench, run it up, make sure it's stable and safe. When MOSFETs hit that point of failure with heat, it is permanent. Unfortunately, like that damage, there's no coming back from it. But you've found where that failure point is, and I would say if you're unsure, just throw a heatsink on and use the double-sided thermal tape to do that. So I hope that helps. And Tony asks, does the Arch Mix SBC come with the secure JTAG fuses set? So the Arch Mix SBC is a dev board by Seed Studio, and I'm not sure, to be honest. If somebody else knows, please jump in, help out. That'd be great. But I'll have a look around, Tony, and I'll let you know what I can come up with. Evan asks, let's scroll back up here. Okay, so Evan's doing some work with RS485, has a project on the bake to do a soil moisture sensor using RS485 instead of UART. So RS485 is a bit like RS232, except you can have multiple devices on the same bus, and rather than just having a master-slave arrangement. And it's probably maybe someday down the track we'll connect many more. And so this has been a great conversation, and Evan has shared his update. Good on you, Evan, for sticking in there. And you've given the DF Robot wiki page a fair go. You've still run into problems, and you're not sure. You're simply not sure if your shield is operating correctly. Everyone's been there before. When you're working with serial communication, it's very difficult to tell if something's working the way it should or not. There are some products out there that can help. You could build your own little debugging platform with an Arduino and a shield. You're already there, and you're not getting it working the way you want to. But a handy piece of test equipment for something like this would be a 4S RS422 or 485 cable to USB adapter. So you'll get this cable, and you'll also get this little adapter here, where the end of that cable plugs into here, and that breaks out the RS485 wires. So that should be quite useful if you just can't see what's going on. So when you're connecting those wires, it's very hard to tell if things are working the way they should, and if the characters or the letters that you're sending over that serial bus are arriving the way they should be. This will let you look into that system, and you'll be able to use it to monitor what's happening. And you can actually use the software, which is down here. There's a little CD driver that comes with it, but it works with like Windows and stuff, and you'll be able to basically use this to drive comms back and forward, and just to witness what's happening on that bus. So I hope that helps, Evan, and I'll share that link in the forum soon after. And Donald has asked, he's looking for recommendations to cut off the legs of SOP packages. It works on PCB yesterday, had some SMD and through hole caps. Had to cut off the SOP8 op amp package and then desolder. Wow, that's definitely one way to go about SMD rework. So I guess this is definitely one way to go about SMD rework. I can just imagine it. You're cutting the SMD pins around that device, and then you're using a desolder or solder wick to remove the solder away from each of those legs. I would consider using a hot air gun, but if you don't have one, then what you're doing is fine, and it's going to work anyway, because you just heat things up after you've cut them and push them off. So it's probably about the same amount of time either way when you consider the finicky nature of hot air rework. You're going to need some good flush cutters, though. Flush cutters, which you just search flush cutter on our website. Here we've got getting ahead of myself. You'll see that the flush cutters will actually have like a very sharp edge. That sharp edge goes down, and then it's flat on the back. So it's like an angle. How do I show that? It's an angle like this meets an angle like that, and that's the middle point. So it's flat on the bottom. It's flush, and that's going to let you get a like a clean cut and a flat cut on each of those points. Nice little pointed ends on them as well. So you're going to be able to get in there and make those little snips. But they're only as good as they are sharp. So while you can rework them, you'll get good longevity out of a good pair of flush cutters. And while we're just talking about flush cutters, everyone's been there before that has done repairs and has worked on the bench. They're a really handy tool to have, and they just really do beat the cutter on a set of pliers that have more of like a chisel cut, not chisel, but more of a triangle type cut, because it's going to press and swell out the component or the thing you're cutting, and it's just not going to be as clean or as good for rework. So that's what you're looking for. While a lot of people are familiar with those tools, clearly, Donald, you haven't been down this road before, and I hope that information helps. And lastly, on Ask a Maker, I've been really enjoying this forum thread. So Don reached out a little while ago, and I talked about it on episode 2. But here I am on episode 3 with a little bit of an update. He's still finding his way around what servo or pneumatic or linear drive system he's going to use to change gears on the bike that he's building. But good on you, Don, for sharing this. But this is Don's build from last year, and wow, like I've gone through and I've had a read of the write up. Great build, great project. Thanks for sharing that, Don. I hope you can get some value, some insight out of the discussion that's happening in our forum. And I really look forward to see what happens with this part of the journey, getting that shifter in place as well. So thanks for sharing that update, Don, and please do keep us in the loop. And just a reminder to everybody that if you are building a project, mosey over, click on projects, and click share the project, share your project, fill out a little form. We'll shoot you a store credit to help with the build on your next project. But we'd love to share it. We want to see it, we want to share it. It's all about the project. So if you've got something on the bake, take photos on the way through, and please do come in and share that with us. Well, that about covers it, everybody. So we've looked at the new Raspberry Pi HQ camera, the 6mm lens, and the 16mm telephoto. We've hooked it up. We've run some commands. I'll share like what I've done in the write up soon after. I'll do a guide just for this camera and the commands I'm using to experiment with it, and I'll do a guide on how to live stream with it. Maybe not live stream, but stream video using it like a DIY security camera system, which will work just as well using the second generation camera with the 8 megapixel sensor, but also it'll work with this as well. So if you have any other questions, feel free to reach out on the forum. But until then, thanks for tuning in. This is Core Electronics Live, and been fun. Enjoy the rest of your Monday.